Hi friends, we are here learning all about the tools of algebra in chapter 1, and today's section is going to be section 1-1. So here's our vocabulary for this lesson. We have three vocabulary terms: numerical expression, evaluate, and order of operations. Numerical expressions are expressions that contain numbers that are combined with addition, subtraction, multiplication, or division. So an example of numerical expressions would be 3 plus 2, 4 divided by, 2, all of that multiplied by 5, I suppose. We could have any variety of grouping of letters, not yet anyway, of numbers and operation signs to form a numerical expression. I want you to notice that numerical expressions don't contain an equal sign or anything like that. And we'll talk about that later when we get into algebraic expressions. Anyway, so that's numerical expressions. To evaluate is basically to solve a numerical expression. So you're looking for a solution to a numerical expression. And that would just be me taking 3 plus 2 and figuring out that it is 5, or taking 4 divided by 2 times 5 and getting 10 as a result from that. All right. The next thing that we need to talk about is order of operations, which I hope you all are very familiar with, but I'm going to emphasize one key point. Order of operations really just gives us a framework for attacking any problem we ever have, and that framework tells us what to do first, right? Hence the word order in the order of operations phrase. Okay, so here's the deal. We all know it's please excuse my dear Aunt Sally, and I like to write it just like that because parentheses, okay, exponents. Here, M and D are side by side because multiplication and division are equal in power in terms of precedence that you need to address them. So with multiplication and division, you need to do them at the same time, but you're going to go from left to right. So I'm going to do multiplication and division. Multiplication, I can spell, I can, and division, all right, from left to right. And similarly, addition and subtraction, or ANS, are side by side here because the same thing applies. Okay, so addition and subtraction from left to right. Let's go ahead and look at an example. So here's our first example, example 1. We're going to translate phrases and expressions. So here we're going to use the information to write a math expression. Very simple. You guys have done it 1,000 times. Let's look at part A. So it says the total amount of money if you are given $9, then $12. Okay, I'm not asking you to evaluate it. I'm asking you just to translate the expression into a numerical one. So we are going to write, first, if you're given $9 first, you've got 9 plus 12. Not a big deal. The next question, or the next problem we have, is the age difference between a 45-year-old and a 73-year-old. When we think about difference, we generally take the bigger number and subtract the smaller number. And so that's the expression that we have. So difference means subtract. The amount of calories, part C, the amount of calories in 7 donut holes if each has 75 calories. I hope you recognize that if each donut hole, each of the 7, has 75 calories, you're going to be multiplying that to get an answer. So I'm going to use a dot for multiplication. The number of groups created within a class of 21, where each group has 3 students. So if we've got 21 students, and we've got to put them in groups of 3, it looks like we're going to be dividing by 3. And so there's our first example. Not too hard, right? Let's take a look at this one. All right, so now we're going to evaluate each expression. And what we're going to use our tool for evaluation, which is order of operations. So let's take a look. So we have 20 minus 3 times 6, order of operations. Please excuse my dear Aunt Sally. There we go. So order of operations tells me I'm looking for parentheses, don't have them. Looking for exponents, nada. But I have multiplication, which supersedes subtraction. So the first step is that this is going to be 20 minus 18. The next step is I can do whatever's left because it's the only operation, and so my answer is 2. Let's follow along with this one. Over here, you notice we've got both division and multiplication. I have to be honest, back in the day, like way back in the day, I used to believe that multiplication superseded division because it came first, and it doesn't. They are equal. So in this case, this is a great example of doing it from left to right. So in this problem, we're going to take 30, we're going to divide it by 5. When I do that, I get 6, and then I'm going to divide that by 3, and I get 2. And that's my answer. Look, 2 2's. Okay. So this next one here does have parentheses. So I need to do what's in here first. I'm going to use a new color so we don't get confused. So 10 minus 7 is 3. So I've got to do what's in the parentheses first. So I've got 3 there plus 2 times 3. All right. Now I want you to know, if you don't know it now, you know, when there is when there's a number outside of a parenthesis, what that means is that you're going to multiply that number with whatever the result of the thing that's in the parentheses. So here we've got 4 times 3 and we've got 2 times 3. Multiplication is in both places, but we're going to go from left to right. 4 times 3 is 12. 2 times 3 is 6. And so now I'm going to do the final thing, which is to add. So 12 and 6 is 18. The next problem we have not only has parentheses, but it also has brackets, which are sort of parentheses. They're like distinguishing parentheses. So when we have problems with parentheses and parentheses or brackets and parentheses, we're going to go deep into the middle. We're going to go there and start and then work our way out. Again, let's point out the operations we have. We have multiplication here. We have subtraction, addition, and division. So we're going to take that in stride. So it's the first thing we should do is go to the outer brackets, and then after we go to the outer brackets, what's the first thing we're going to do inside the brackets? The inner parentheses. So the first rewrite of this problem will look like this. 5, I'm going to leave my bracket there, 11 minus, I'm going to do that, 7 plus 5 is 12, divided by 4, close bracket. Still got to do what's in the bracket first, so I'm still dealing with order of operations within the bracket, right? 12 divided by 4 is the first thing that I need to do because division supersedes subtraction. Remember this thing? Okay, so 12 divided by 4 is going to give me 3. So my rewrite is going to be 11 minus 3 times 5. 11 minus 3 times 5 is what I have. I'm going to finish the 11 minus 3. We know that that is 8. And then when I multiply 5 times 8, voila, I get 40. Does that feel okay? All right. Take a look. Make sure if something's not feeling right or if you got a different answer, let me know and we can talk about it when I see you. All right. This final problem I'll do in red. Actually doesn't seem to have a whole lot going on. But if you remember, this is a division symbol. Okay, so the fraction bar is division, and we need to keep that in mind. And when our fraction bar also does something really interesting, it actually puts kind of magical parentheses at the top and the bottom, meaning you've got to simplify the top, the numerator, you got to simplify the bottom, the denominator, and then you can proceed with the operation you need to do, which is the division. So we're looking for a quotient. That's a word we'll talk about a little bit later. A quotient is the answer to a division problem, all right? But first we've got to simplify what's going on up at the top and at the bottom. In the denominator, I've got 2 plus 7, which is going to give me 9. In the numerator, I'm subtracting 15 from 60, and I get 45. Now, finally, I do the last thing, which is that division, and I take 45 and I'm dividing it by 9, and I get 5 as my final answer. Okay, let me just recap really, really quickly. I know that we have PEMDAS, and it looked like we should probably do the division first, but when we have a fraction bar for division, it automatically puts parentheses around the top and the bottom. And we know when we have parentheses around the top or the bottom, we need to do what's in the parentheses first. Hence, we got our answer. I hope that makes sense. Let me know if it doesn't. Let's go on and check out what example 2 is going to give us. Example 3. Example 3, the real world example. A cell phone company charges $20 per month and 15 cents for each call made or received. Write and evaluate an expression to find the cost for 40 calls. Then make a table showing the cost for 40, 50, 60, and 70 calls. All right, this seems like a lot of work. Let's get started. So as I look at this, I'm thinking about the fact that this problem is really about 1 month, what's going on within a month, and we're going to think through how we can kind of access the answer to this question. So how much would it cost for 40 calls? Then we have to calculate 50 and 60 and 70 calls. Well, what I know is that there's going to be $20 that's charged just at the beginning of the month. And then per call, I'll be charged 15 cents. So I feel like this is probably the best way to set it up because I know I've got to do that. And then at the end of the month, I'm still going to add that $20 cost. Make sense? So here is what we need to do. In order to utilize that to answer the first part of the question, the cost for 40 calls, we're going to take $20. We're going to add to it 0.15 times 40. When I do this, I'm going to be able to get my answer. So I get $26 as the final answer. So now we need to make a table checking out or detailing what we know. So here's what I got. I am going to draw a straight line, make the table. So the table is going to be the number of calls and then the cost per month. The total cost per month, that is, okay? So if I made 40 calls, I saw that that was $26. How much would it cost me for 50 calls? So what I'm going to do is take 50 and plug it right in here and get my answer. Okay, so I took the liberty of filling this whole thing out, and I'll talk about how we got the answers. So the answers would be 40 for 40, 26, for 50, $27.50, 60, $29, and for 70 calls, $30.50. The way that we got that is by using this formula here that we kind of created. So we have 20 plus 1.5 times the number of calls. So in this case, I put in 40. To get this answer, I did 20 plus 0.15. Keep messing that up. I said 1.5 last time, my bad. Times 50, and I got that answer. And you can check, and if I make a mistake, you'll let me know, I'm sure. And that's how we do it. And here's our beautiful table to prove that we know what we're doing. All right. That's really it for today, or for this lesson anyway. Your assignment is in the cover of your assignment packet. I do have an assignment here, but I think you have it, and it probably makes sense for you to just do that. It's always a pleasure. I look forward to talking to you, and I can't wait to see you tomorrow. Take care.